It may be difficult to accept, but nothing lasts forever, not even the overwhelmingly distant celestial bodies such as stars. Astrophysics therefore observe the universe around us intently so they don't miss out on any changes occurring in the vast, ever-expanding cosmos. In recent years, a red supergiant has grabbed their attention, and now every single move it makes astonishes them. Using historical evidence and state-of-the-art modern telescopes like the Hubble Space Telescope, scientists have been able to find out some mind-blowing things about this incredibly bright star. And the most perplexing of these findings suggests that something might be going on with it. The red supergiant of spectral type M12 has been named Betelgeuse, and it's one of the largest stars in the universe that's visible to the naked human eye. In the night sky, Betelgeuse is usually the 10th brightest star, but in the constellation of Orion, it is regarded as the second brightest, number 1 being Rigel. Betelgeuse is a distinctly reddish, semi-regular variable star with an apparent magnitude varying between 0 and 1.6. It is the widest range displayed by any first magnitude star. At near-infrared wavelengths, it is the brightest star in the night sky. The biodesignation of Betelgeuse is Alpha Orionis, and it's abbreviated as Alpha Ori. The traditional name of this star has been derived from the Arabic term Yad al-Jauza, which translates to the hand of Al-Jauza. Because of an error in the 13th century AD, the Arabic Ya was read as Ba, and that is what led to the European name Betelgeuse. Back in 2016, the International Astronomical Union organized a working group on star names in order to catalog and standardize proper names for stars. In their first bulletin of July 2016, the name of Alpha Ori was included as Betelgeuse, so now it is officially entered in the IAU catalog of star names. Now, if Betelgeuse was at the center of our solar system, its surface would lie beyond the asteroid belt, and it would engulf the orbits of Mercury, Venus, Earth, and Mars. According to calculations, the mass of Betelgeuse ranges from under 10 to a little over 20 times that of the Sun. Measuring its distance has been quite a challenge for astronomers. However, their current estimate suggests that it lies 500 to 600 light-years from the Sun. 100 light-years is a relatively wide uncertainty of a nearby star. The absolute magnitude of Betelgeuse is around 6. The supergiant is less than 10 million years old and has rapidly evolved because of its large mass. Experts are expecting it to end its evolution with a supernova explosion, most likely in the next 100,000 years. Betelgeuse is actually a runaway star that was ejected from its birthplace in the Orion OB1 association that includes the stars in the Orion belt. Betelgeuse has been observed to be moving through the interstellar medium at 30 kilometers per second and creating a bow shock that is more than 4 light-years wide. Back in 1920, Betelgeuse became the first extrasolar star to have its photosphere's angular size measured. Later studies revealed an angular diameter ranging between 0.042 and 0.056 arcseconds. The star is also surrounded by a complex asymmetric envelope that is almost 250 times the size of Betelgeuse and is produced by the mass loss from the star itself. According to scientists, the Earth-observed diameter of this star is only exceeded by that of R Doradus and the Sun. The red coloration of this magnificent star has been noticed since antiquity. Ptolemy, the famous astronomer, described its colors as rubedo, which is Latin for ruddiness. Another renowned astronomer from Italy, Angelo Secchi, included Betelgeuse as one of the prototypes for his Class 3 stars in the 19th century, decades before the modern systems of stellar classification were devised. In fact, almost 300 years before Ptolemy, astronomers from China observed the giant star having a yellow color. Aboriginal groups in South Australia have also shared tales of the varying brightness of Betelgeuse for almost 1,000 years. It's not surprising since the distinctive orange-red color of Betelgeuse makes it hard to miss even with the naked eye. It is one of the 3 stars that make up the Winter Triangle asterism. It also marks the center of the Winter Hexagon. It can be spotted rising in the east just after sunset at the start of January. Between mid-September to mid-March, Betelgeuse is visible to every inhabited region of Earth except in Antarctica at the latitudes south of 82 degrees. The variable star even surpasses Rigel to become the 6th brightest star, and sometimes it will become even brighter than Capella. It has a VB color index of 1.85, which testifies to its pronounced redness. Betelgeuse is now considered a single isolated star, not associated currently with any closer or star-forming region. Now, it may be large and luminous, but it's actually a cool star classified as an M12 LAAB red supergiant. Since 1943, the spectrum of Betelgeuse has served as one of the stable anchor points by which other stars are classified. In 2004, astronomers used computer simulations to speculate that even if it isn't rotating, Betelgeuse might exhibit large-scale magnetic activity in its extended atmosphere. Later, in 2010, a series of spectropolarimetric observations obtained by the Bernard Lyot telescope from Pic de Midi Observatory confirmed the presence of a weak magnetic field at the surface of Betelgeuse. There's still a lot to figure out about Betelgeuse, but in the last few years, scientists have made some promising breakthroughs and have also pinpointed roughly when the supergiant star acquired its red coloration. They used historical depiction and descriptions of Betelgeuse to determine this. The team of astronomers discovered that the star changed its yellow-orange color to red approximately 2,000 years ago. Betelgeuse is now in the red giant star stage, which stellar bodies go through when they finish burning hydrogen in their cores. This in turn causes the core to collapse and the outer layers of the star puff out. According to experts, our Sun will go through this stage of evolution in about 5 billion years, and it will swell out to a radius reaching around the orbit of Mars. This means it will consume the inner rocky planets of the solar system, including Earth. Astronomers already know that stars shift their colors during their lifetimes as nuclear fusion consumes the hydrogen in their cores. These color swaps are also accompanied by changes in brightness and size. They can also provide significant information about the age and mass of the star. Stars that are much more massive than the Sun tend to be blue, white, or red. But as they transition from hot, young blue stars to cooler, older red giants, they go through a short yellow-orange phase. And studying the historical documents has helped researchers determine that Betelgeuse went through this state around 2 millennia ago. One of the sources this team used was a Chinese court astronomer named Sima Qin, who wrote about star colors in 100 BCE. In his notes, Qin describes star colors as white is like Sirius, red like Antares, yellow like Betelgeuse, blue like Bellatrix. Then, almost a century later, Hyginus, a Roman scholar, also wrote that Betelgeuse had a color resembling that of Saturn, indicating that the supergiant star actually did have a yellow-orange hue. Astrophysicist Neuhauser and his team used a process called terra astronomy while conducting this study. In this process, astrophysical research is mixed with work studied by researchers in diverse fields like languages, history, and natural philosophy. According to Neuhauser, the view back in time delivers strong impulses and important results. There are quite a number of astrophysical problems which can hardly be solved without historical observations. Despite being one of the brightest stars in the night sky, Betelgeuse undergoes cycles of dimming roughly every 425 days. During this period, it temporarily loses almost 1/4 of its peak brightness. But something strange happened in February 2020. Astronomers noticed that the brightness of Betelgeuse unexpectedly dropped by 2/3, which is enough to be noticed by the naked eye. This unexplained dimming was alarming as it suggested that the star could be about to explode. Now, the star is expected to explode in the future, and experts believe that the supernova explosion would be a mind-boggling spectacle for the inhabitants of Earth, as Betelgeuse is so close to us that its supernova will be bright enough to be visible during the daytime. Although many astrophysicists have stated that the supernova speculation is wishful thinking, they also pointed out that this sudden dimming was most likely caused by more mundane mechanisms like a blob of extraordinarily cold matter appearing on the surface of Betelgeuse or a cloud of dust crossing the line of sight. And astrophysicist Miguel Montagues from the Paris Observatory and his collaborators confirmed that the reason for this great dimming was most probably a combination of both. Using the Very Large Telescope in the Atacama Desert, the team took a series of high-resolution images of the star in January 2019, December 2019, January 2020, and March 2020. Montagues, who has been studying the star on and off for almost 10 years, explained that Betelgeuse is one of the few stars that astronomers can actually resolve as a disk rather than as a single dot of light. The images taken by the researchers clearly showed that the bottom left part of the star had dimmed dramatically and that the darker region's position didn't change substantially over the imaging period. This suggested that the dim spot was produced by a cloud of dust that the star itself spewed, and it was moving in the direction of the line of sight instead of just passing by. According to Montagues, if it had been one cloud transiting, it would have crossed the star. The team thinks that an unusually cool convective cell led to a drastic drop in the temperature of Betelgeuse's atmosphere. This enabled gas spewed out by the star in the previous year to rapidly condense into dust, which in turn blocked out light from the star. This scenario best fit the data, and the researchers, after running more than 10,000 computer simulations, concluded that the modeling is that both events happened at the same time. Because of the Great Dimming Event and the absence of sufficiently detailed understanding of Betelgeuse and other red supergiants, this famous crimson star has been a hot topic among astronomers. And the new data from NASA's Hubble Space Telescope only added to the speculations, as many now think that the unprecedented dimming may have been caused by Betelgeuse blowing its top off. After analyzing the data from HST and several other observatories, astronomers have now confirmed that the supergiant literally blew its top in 2019 and lost a substantial part of its visible surface, thereby producing a colossal surface mass ejection. This is a one-of-a-kind incident that has never been seen in a normal star's behavior. Our Sun routinely blows off part of its outer atmosphere called corona, but Betelgeuse SME actually blasted off 400 billion times more mass as a typical coronal mass ejection. Astronomers have also revealed that the massive star is still recovering from the catastrophic event. According to Andrea Dupree from the Center of Astrophysics, Harvard and Smithsonian in Cambridge, Massachusetts, Betelgeuse continues doing some very unusual things right now. The interior is sort of bouncing. These new observations have provided vital information about how the red stars lose mass late in their lives as their nuclear furnaces burn out. The amount of mass lost greatly affects their fate, but the petulant behavior of Betelgeuse does not indicate that the star is about to blow up soon. Dupree has also said, "We've never before seen a huge mass ejection of the surface of a star. We are left with something going on that we don't completely understand. It's a totally new phenomenon that we can observe directly and resolve surface details with Hubble. We're watching stellar evolution in real time." The titanic burst of 2019 produced shocks and pulsations that blasted off huge chunks of the photosphere, exposing a large cool surface under the dust cloud that was produced by the cooling piece of photosphere. Betelgeuse is currently struggling to recover from this potentially fatal injury. The dust cloud that contributed to the anomalous dimming was also produced by the fractured piece of photosphere that sped off into space. But what's even more mysterious is that the 400-day pulsation rate of the red star is now gone. At the moment, experts think it's temporary, but only time will tell. In Dupree's opinion, interior convection cells that drive the pulsation could be sloshing around like an imbalanced washing machine tub. The data from Hubble and TRES may suggest that the outer layers are back to normal, but the surface is still bouncing around like a plate of gelatin dessert while the photosphere rebuilds itself. Scientists are super excited to find out what the Betelgeuse supernova will look like from Earth when the star does finally explode. Andy Howell, an astronomer from the University of California, Santa Barbara, got tired of the back-of-the-envelope calculations, so he put together a pair of UCSB grad students, Jared Goldberg and Evan Bauer, to solve this problem. The two subsequently created much more precise simulations of the star's dying days. According to them, it's still not very clear how the supernova will play out, but they did manage to augment their accuracy using observations taken during the 1987A supernova. They think the Earth won't be harmed, but when Betelgeuse does explode, it will shine as bright as the half moon for more than 9 months. All that brightness will be concentrated to one point, so it will look like an intense beacon in the sky that would cast shadows at night. It would be hard to miss, and humans will be able to see it during daytime for at least a year. And by the time it finally fades, Orion will be missing its left shoulder. However, there's almost no chance that the supernova explosion of Betelgeuse will happen in our lifetimes. But according to the new simulation by Goldberg and Bauer, wherever it happens, a good fraction of human population will stay up and watch Betelgeuse for the light show to begin, and it will definitely be a magnificent sight.